Hello everyone, welcome back. So I hope you all are enjoying the conference so far. I know it's a very long tracks, but we had really interesting sessions, and then we have now as well. So I hope you took a nice break. So right now we are going to have a session on um, the clear the ring of a chaos engineering at Vertrieb Deutsche Bahn. So we have two speakers here. First is Mac, who is an IT consultant and code-centric agent. And Mac is actually introvert, stammer, and loves to give the talk. But what could possibly go wrong? So at Concentric AG, Mac helps customer to establish chaos engineering practices, and his plus one time he is maintaining Chaos Monkey for Spring Boot. And our second speaker for this session is Oliver, who is an implementation lead at Deutsche Bahn. And Oliver works at DB Virtual Deutsche Bank as an implement lead, as I mentioned. His hobby horses are implementing DevOps, software craftsmanship, as well as adopting the cloud technology. And they are here to talk about how they do chaos engineering in Deutsche Bank. So over to you, folks.
Thanks.
Right, start the sharing. So, hi, I'm Oliver. Yeah, great to be here at Carlos Carnival. Well, unfortunately, today we didn't bring an amusement ride, but maybe we have something different, so don't be too upset. Welcome to our Chaos Engineering Circus Show. If you now think, whoa, wait, circus, what circus? I was thinking it's about chaos engineering. Well, sit back and relax. I assure you are in the right talk. It's all about chaos engineering. Why are we talking today about chaos engineering at Deutsche Bahn? Yeah, there's a simple answer. We do chaos engineering for over a year now and want to share our experiences. And the more or less long story is our IT systems are historically grown up to a point where we had to renew them. They were decades old. The support is discontinued for the technology. We had a lot of brain drain. And of course, these systems are not cloud ready. With our new platform, we have the possibility to roll out stable features and changes within hours, whether it's weeks or months. But all of you know that comes at a cost. We have more teams, more people, new technology, which we have to learn, new processes, and of course, the old monolithic world still plays a big part for now. So new challenges everywhere. In this talk, we focus on the implementation and operation of chaos engineering and how we integrate chaos engineering in our daily work. On our journey, we took a lot of detours. Yes, this was hard. We made errors and had burdens and hazards. We talk about how we got on track again, in the hope that you will not be caught by our mistakes. But what's this circus thing now? Well, we see parallels between the organization of a circus and how software development might be organized. You can tell us afterwards if you also see some analogies. To give you some context, who's Deutsche Bahn and what is Deutsche Bahn Vertrieb? Well, Deutsche Bahn is the biggest train operating group in Germany. And Deutsche Bahn Vertrieb is the interface between the customer and his train ticket. So that is a short story. Basically, we sell train tickets, and for that reason, we develop software systems to support that. Customers can buy tickets over multiple channels, vending machines, mobile applications, online, and of course in person. When there is no pandemic, we sell a couple of million tickets per day. Now you know what we are doing. Let's look at what we are talking today. Our topics. First of all, let's talk about the roots of our historical systems and what kind of systems we have now. Then we try to discuss the point if chaos engineering is really a magic wand which turns every system in a super robust and resilient platform. And fire drills. Yeah, fire drills are practiced everywhere. On ships, the firefighters, of course, do this. And in the circus, it's a good practice. And why don't we do fire drills in the development? Maybe that's a good idea. In the game day, in the context of chaos engineering, we call fire drills a game day. Later on, we explain the context behind game days and other chaos engineering practices. And our top 5 excuses. Yes, it's always a reason not to do things. Here we talk about the most frequent and absurdly excuses and how we react on them. And our top 5 lessons learned are the most painful experiences while rolling out chaos engineering at Deutsche Bahn Vertrieb. What gives chaos engineering to us? So principle of chaos states that chaos engineering makes my system capable to withstand turbulent conditions in production. That sounds great. Why didn't do everybody chaos engineering then? Well, this is a good question. What I know is the value that chaos engineering gives to us. It helps us to discover unknown technical debt. It helps us proving and verifying our non-functional requirements. And very important for the management, also, it lowers the time to recovery and increases the time between failures. For proving the success, you should measure these metrics from the beginning. And finally, by the adoption of chaos engineering, we gain more resilience and robustness, as well as a better understanding of the processes in case of failure, because failure is a great teacher. And now, welcome to the show. Let's have a look at the actors now. Yes, the good old times. This was called the monolithic age. The show was very well known and no surprises for the audience. This show was very predictive. We only had 1 or 2 tents, painted in blue, and a sign that said web sphere. Yeah, this was very sturdy and durable the last decades. But the surrounding parts of the system were much older and programmed in languages which I either haven't heard of or treated the name a fairy tale. So with this setup, we could not fulfill the demand of the new modern customer because it took us nearly 3 months to change a show or introduce a new act. And today the audience requests 24/7 shows or even multiple shows in parallel. In contrast to operations, operations love this show. Very stable and no surprises. But business and developers, they want change. They want new features delivered to the show. And they want them delivered fast and at a modern cadence. Yeah, there's much more going on here. And this is how our show looks like today. Now we have more tents. 24/7 shows, even multiple of them in parallel. And the best of all, these shows are updated while they're running. What have we done to support that? Yeah, as you can see, we changed everything in our software delivery process. We moved to a cloud-ready technology stack. We scaled up the number of teams. We used some sort of domain-driven design to separate our concerns. Continuous deployment also enabled us to change the show while it is running. Our quality assurance, had a mind change from manual testing processes towards fully automated testing. And also new processes had to be set up to support all these changes. For example, to have a new incident process and operation procedures. Think about it. Having a powerful CI/CD cannon, which allows you to shoot features directly to production systems. Imagine what could happen if you change the actors jiggling to chainsaws within a Git commit. Well, the question is, what could possibly go wrong? We had an error. The first feature we released in our new platform was KCI, also known as Comfort Check-in. The feature allows you to check in at a seat, in a train, and you will not be bothered by the conductor asking for your ticket. Now you have quality time while traveling by train. Well, have a nap, that's great. This was the first feature, which connects the new platform and the current old monolith. And guess what happened at Friday 5 p.m.? The new feature went silently down. Customers start complaining online. The DB social media team's weekend was moving far away. So what has happened there? No time for analysis, restart the services, and keep fingers crossed. Services start working again, but the error has had side effects and was not only affecting KCI, our new feature. We encountered a cascading error as customers could no more download their already bought tickets. This was a serious problem and a really, really bad thing. At Friday 5 p.m., people usually want to get home by train. As a result, more complaints, more headlines on big newspaper websites. There was one good thing. We didn't make it to prime time news this time. The only reason for that was the incident managers did a great job coordinating the fix of the issue. But afterwards, uncomfortable questions were asked. Concerns regarding our new platform were expressed. From all directions, the most important question was asked. And I bet you know what the most important question after an outage is. Well, yes. Who is responsible for that outage? Who is the guilty guy? Well, a postmortem revealed it very efficiently. So, job done, we know who's responsible. But we have asked the wrong question, because only knowing who's responsible will not prevent us from further outage. It's more about asking why did we fail, instead of who is responsible. We had to learn that. As a quick fix, we have added an adjective, blameless, in front of the postmortem. So continuous improvement already started. But remember, we have had changed everything. Technology, culture, responsibility, processes. And also with this old monolithic system, which is still running, which is operated completely different. So we agreed that something has to change. That's what we all agreed on. The question was, but what? And Maik will tell you about some of the ideas we came up with.
Yes, thank you, Olli. So we're all agreeing on that something has to change. So what we did is we sat together and we had all the departments there, architecture, development, ops, quality assurance, and everybody had good ideas, So architecture was asking for more governance, the development teams were asking for more code coverage, operations needed better tracking, and so on. And I mean, at some point you have to decide to do something, right? If you don't know any better. So, well, one question you can keep in mind for a while is, do we need more of, everything? Well, now we know we don't, but back then we didn't. So what we did is we decided that we need some sort of special testing to avoid such problems. And to know what testing we needed, we thought back what we actually wanted to achieve with the new platform, which was getting faster with less errors and a better UX, basically making customers happier. So what we did is we introduced tests on the two sides of the wall, because at Deutsche Bahn back then, operations was a completely different department. They never talked to the developers, right? Actually, there was like a big fence between those two departments. So whenever you had something ready from the development side, you just threw it over the fence. So we said, well, development, you have to do performance testing. And they did. And they made their checklist screen, and it was awesome. And operations, we had said, well, you have to do testing for all the operation, right? So do rolling updates. And they did rolling updates. And rolling update checklist was green. So the idea was simple, do all these tests and then go to production and everything will work, right? So, well, that didn't really work out. Spoiler, that didn't help. So this time we thought, well, something has to change this time for real, right? And, well, we did what every good company does, and we asked ourselves, what would Netflix do? I know that sounds mad. We're not Netflix, right? But let's look at it. I mean, we have a good load of microservices. So the complexity is similar, and we have the same problem or similar problems. Well, why Netflix? Because, well, they're very known for being cloud native and they're doing all the good stuff. And so they developed chaos engineering. I mean, you all know that, I guess. So, well, they mitigated all those problems we were facing much, much better than we did back then. So we thought, why not, right? So, yeah. I mean, we're not Netflix, but look at it. This is like a real screenshot from our monitoring system. And those little buttons you see there are actually teams and little domains, like a payment, for example. That could be one button here. And you can see, well, it maybe looks sorted and not too complicated, but what you have to keep in mind is we have a complex technical system here and also a complex socio system, right? Because every button is like a team with different approaches, a different culture, a different experience even. And even though we decided to have guidelines for all the teams, right? Like you have to build robustness and resilience into the system, obviously. I mean, why not, right? So, but yeah, that still didn't work out, obviously. So we tried Chaos Monkey. Chaos Monkey to the rescue, right? So on the shoulder of giants, we thought, well, let's use the Chaos Monkey for Kubernetes. And we even asked operations about it. So we put the monkeys to good use and fired.
Yes. So without knowing much, we just deployed the monkeys. And they did a great job. They killed pods and containers in one of our gazillion environments and really doing chaos. But to be honest, we didn't really know what we were doing. Because, as you know, a fool with a tool is still a fool. And so you can guess how that worked out. Yes, it ended in tears once again, because the services were not prepared and our environment also was not prepared. And we started too big. But that wasn't the worst thing. The worst was nobody noticed really. So at this point, we didn't have the observability to even detect these errors and these chaos which was produced there. Simply to say, we were not prepared. We didn't do our homework. Without much of a plan, we did dangerous, really dangerous things. We felt like chaos engineering has won the worst initiative of the year award. This was quite depressing. There was only one last chance. Do our homework and start over at the drawing board. So was Miles. When this side from Russ Miles said something about thoughtful and planned and socio-technical system. Yes. What did we do? Well, we didn't think. We didn't plan or experiment. We just deployed something. So we violated every principle of chaos engineering. and we started over with chaos engineering again. So, okay, let's start over. This sounds great. And what do I need for that? All these monkeys and warthogs needs accommodation, so maybe we should buy some new cages. And yes, these animals and weapons have to be trained, so special trainers are needed. Get some consultants to develop Excel-based meal and training plans. And of course, get all departments at the round table and design a process that printed out hardly fits on the walls of a meeting room. And of course, what cost nothing is no good. So open the treasure chest and bring a big budget.
Stop, Ollie. Oh. I'm not sure we need all of that. Actually, what I learned is you don't need any of that to start with chaos engineering. You just need to start doing chaos engineering. You have to pick an aspect of the system you want to experiment on. Plan your experiment. Prepare your environment. Measure your steady state, monitor your system, and then conduct it. I can't see any cages, big budgets, or anything else here on that slide. So I guess you just have to start in doing it. Have a leap of faith and try it with a small experiment. And that's what we did. But how does it look like at Deutsche Bahn? Well, it looks like this. This is like operations, architecture. Ollie is there with a much smaller beard than now. Me, ops, and dev. And well, let's come back to our little first game day story, the rolling update and the performance testing. Well, it was really funny. So one of the first game days, we actually thought what could be a really nice experiment. And so we put all the people together, like shown on that picture, and we had the development people there and ops. And there were people with more than 20 years experience. And before we did our first experiment, we asked whether something will go wrong. And we were all sure nothing will go wrong, right? It was like, yeah, it's no problem. We were developing this thing for like a year, so this will work. So our first experiment was, let's do a rolling update, but with a real production load. And well, guess what happened? It actually ended almost in tears because the error rate was 100% for 15 minutes. And to be honest, it was kind of depressing for everybody. And we expected some errors. Well, if you update something, it's okay. But we didn't expect 15 minutes of failure and broken services. And we were using Kubernetes. So, I mean, if you use Kubernetes, everything will work out of the box magically, right? So there's nothing to do there. Well, the good thing was, it was kind of a wake-up call for everybody. And on a side note, after that, we never had to buy management in. They were always on our side. So, and we basically noticed something else, basically that we had a gap between dev and ops, which we kind of mitigated in one of the first game days already because they talked to each other for the first time in real. I mean, in all the times with the virus, it's maybe a bit more problematic. You have to do it remotely, but it still works that way, right? So, what's the value for us in chaos engineering? Well, we use game days to gather peoples together, right? In order to validate our non-functional requirements and our functional requirements, basically. We ask ourselves, what would the customer see if we do something, whatever that is? It increases the team communication. We try to find the unknown technical debt, the technical debt you don't have in your Jira or in any other issue tracker of your like. The technical debt that customers will find on Saturday evenings, right? And for us, we reduce time to recovery. And we increase the time between failures. And for us, that increases the overall resilience of the system, which is really important if you're selling train tickets in Germany. So what tooling are we using? Well, basically, one thing we noticed is that you have to use a great application performance monitoring solution. Whatever you use, it doesn't really matter. As long as it's a good product and a good solution that really works for your developers and for your operations and for all the other teams who have to do the actual work. They need to like that tool. If that's not the case, then it's not okay and it's not good. In the beginning, we mostly used Pumbaa and Chaos Monkey for Spring Boot. That was all we needed. We think that you have to automate later. At some point, it makes sense to look at a sophisticated tooling and a more actually like a big platform or something. But for us, that point came like after a year or something. It wasn't something we thought we need from the beginning. Yeah. And even then, I mean, there is a good GitHub list for all the tools you need. I guess you folks know that. So I will be a bit faster here. So, right, we had all the protective gear in place. Everybody is informed and everybody's there. But we still had some problems to get it started. And Ollie will tell you about some of those problems.
Yes. There are always excuses not to do things. So here's number 5. Go live is in a few days. You are messing up the test plan. In our new microservice world, there's a go live every minute or every 10 minutes, especially when we are starting a new service. So, yes, maybe we are messing up the test plan, but at this point, we see issues like, why do we have a test plan? Didn't we move to fully automated testing? And despite the fact that the teams may have crunch time, please integrate chaos engineering into the test plan then. Or even better, shift left and integrate chaos engineering into your daily development process. In any case, keep talking and make QA a friend and convince that chaos engineering may have experiments which can be the result of these tests can be transformed in a real test in the future. Number 4, we don't have enough access rights. As often this actually means that there is a technical gap. People often do not know where to find the correct information, and some indicating questions are, for example, we cannot access logs nor the monitoring system. And if you ask, have you even tried? Often these problems disappear when talking and discussing with operations. Number 3, we can't think of any good experiments that are useful to us. Oh, yes, this is an alarm. Also, your effort in implementing and operating chaos engineering was not enough. You have to find out the reasons. Maybe they just don't know or are ignorant to chaos engineering. So give them more coaching and explain the gains from adopting chaos engineering. Also try to push the experiments to reflect use cases instead of only thinking technical aspects. Or maybe the game day formats do not fit to them. Yeah, show them other formats. What helps us was giving some standard experiments so they can derive their own. Number 2, there's no time because right now we are only doing features. We take care of technical things later. Ooh, alarm again. Use cases. Technical and non-functional requirements are inherently connected. Sometimes our devs will be forced to make this decision. So we have to insist here. Because everybody knows what will happen when you accumulate too many technical debt in your backlog. It gets poisoned and will eventually be ignored until these debt will hit you in production. This approach is very, very risky. There are many reasons for that. Often the product owner plays an important role in this decision because he's treated or behaves more like a backlog manager than a person who feels responsible for the whole product lifecycle. Number one, we would love to do chaos engineering, but our product owner has no budget or time for it. Remember the last argument about the job of a product owner? Yeah, maybe the product owner has opposing aims and is measured by the cadence or count of delivered features. That comes at a cost. The product stability suffers with this approach, and often this is pushed by management. Yeah, but that's another story. To mitigate his or her possible fear and uncertainty, stress out the value of chaos engineering for the product. Example, show them the value of chaos engineering by doing at least one game day, which is a small scope. So regardless of the excuses, we have done something. So up to now, more than 80 game days done. And many, many product relevant weaknesses. And we gained enough trust to host our first game days in production. And we are very proud of the fact that multiple teams are now hosting their own game days. Yeah, that's a success. And we started different game day formats, red teaming, and what was very useful to us was having a unified documentation, a single entry point in our wiki, and where all experiments from all teams can be seen, and where they can share their findings. So and we build up the community, have breakfast, have podcasts, and now we have our top 5 learnings from Maik.
Oh yeah. So, well, number 5. People, processes, and practices are key factors. I guess you already knew that, but it's all about talk. You have to communicate with the stakeholders, get them together in game days to test the system and to learn more about it. And don't get tired of it. That's the hard thing. Don't just deploy the Chaos Monkey. At least for us, that wasn't really a good idea. Tooling is the least of your problems, at least in our experience. We started with a pretty simple game day. We didn't prepare too much. More important is to share your findings with others so they can learn from them, like the finding of the month or something. It took us half a year till we even thought about automating some of our experience. That was around after 50 game days. So, and remember, pre-major optimization is the root of all evil. So do it when you need it, but yeah, keep in mind that you have to do it at some point. Start small and aim for production. Well, start small to gain confidence. Start where nobody's hurt. Because if you hurt people early, when you introduce chaos engineering, people will not like it. That's the funniest thing. So start in development, go to testing, staging, get people used to it, get people used to that stuff fails, but aim for production. Keep that in mind that at some point you want to have your experiments in production. It's a complete different feeling. It's a good question afterwards, so ask us about our first experiment in production, but it's a completely different feeling when you do stuff in production. Don't be afraid to bug people. Don't get disencouraged. Well, this is maybe something for the long run. If you're the chaos engineer and you want to push that practice in your organization, well, you have to run, and you have to run a long time. We organized the first game days. We moderated them. We took care of the documentation to make it as easy as possible for the participants. We searched for allies like operations or quality assurance. And if stuff went wrong, we took the plunge. And we also did the jobs nobody wanted to do. Well, stay positive or something would be good advice there. But yeah, taking the plunge is basically very important, especially in the beginning when stuff goes wrong. And last but not least, at least for us or in a big company, this is something that you maybe also experienced. Don't get eaten by the process line. At some point, other departments want a piece of the cake, especially as soon as chaos engineering gets more successful. So, for example, in our case, quality assurance wanted to make specific experiments mandatory. So they asked us whether we could always do them in our game days, like making a checklist screen. And we think this is bad because game day experiments should be self-driven by the participating teams because they probably know best what could go wrong and they are the experts. So this. And then you're better off without a checklist. At least for us, that's a good guideline. And there are no excuses. So even big organizations. So, Olli, can you switch the slide? I think I got thrown out. Yeah. So what do we want from you, folks? Well, we basically want you to invite your team to your first game day. Ask around, organize a date. What else? We want you to share your findings with other teams. Don't underestimate that. Documentation is very important for chaos engineering and for the success of it. At least in our experience, it was. And last but not least, we want you to go out and do chaos engineering if you haven't done it yet. Maybe this audience here has done it a lot more than the conferences we're usually at. But anyways, I mean, go out to chaos engineering. It's an awesome thing. And yeah, thanks for listening.
Thank you.
That was a really amazing talk. I mean, astonishing, I would say. I'm pretty sure audience have enjoyed it a lot. I mean, the storyline, I would just give a hats off. It's really good. So let's quickly get few questions from audience. And before that, I would like to get mine. I have 2 questions for you. So first one is, so usually chaos engineering is a fear for an IT admin. So how do you change that attitude? I mean, you have already explained the process, how you all started, but getting rid away of that attitude is also important. So how do you manage that?
Yeah, I mean, we're basically focusing on making the job easier for people that do chaos engineering. So as soon as you start with chaos engineering and we're basically finding stuff they have to do usually, you know. So after a game day, they have more stuff in their backlog, which is usually a bad thing. But as soon as they work through it, there is less to do and less bugs and less unknown work, which comes back from production. So at some point, we have teams that do regular chaos engineering and they are chilled now. It's not all teams, but they get into the mood and then they notice, well, we benefit from it, but it's small baby steps. You have to make it easy for the people. I think that's one mandatory thing. And the rest comes after time. I hope that answers the question. Yeah,
I hope so. So I'm taking questions from audience now. We got a really good questions. I hope you will enjoy it at all. So this one is from Alexander. Is asking, so what tooling you end up using?
So at the moment we try to evaluate steadily for automating our chaos experiments, and the teams at the moment use mostly Puma as we are in a Kubernetes environment, and we have many Spring Boot services. So the Chaos Monkey for Spring Boot is also plays an important role for our experiments.
Mm-hmm. Seems like another follow-up question from the same person. Why Pumba and Chaos Monkey was not sufficient for you?
Ease of use. That's that's the question. I mean, people need to have like no hard time in using those tools, and our developers are not Kubernetes experts. So you have to deploy Pumbaa with a daemon set, and ops has to do it because of rights issues, and you have to ask them. And that's basically like all the little hurdles, right? It's not just one hurdle; it's the combination of it.
Yeah.
And yeah, I know we could have scripted stuff around it, I guess, but we didn't. So yeah, in the beginning that was okay, but after a while, you just want a bit more convenience, I guess.
Yeah, I hope Alexander that answers the question. So next is from Dudu. So she's asking, how are you planning to integrate chaos engineering into your daily development process? How are you going to link continuously DevOps with that?
What we try to do is to give the people more time to do chaos engineering. So at the moment, we focus on giving the teams the time to do chaos engineering, at least a day in a sprint. So, and the more experiments they do, the less time they need to prepare an experiment. And so we talk not about game days, it's more about game hours then. So the more they get used to it, they often practice chaos engineering.
Mm-hmm. So another question is from Om. He's asking, chaos engineering is fear. I guess it's the same question he asked. So another question he asked is, where do we start chaos engineering, staging or production?
I advise starting left as you can. So staging or development. You have to get some confidence in what you are doing. And learn how your platform or application behaves if something went wrong. And of course, the observability is the main important thing here also.
Okay.
Yeah, I actually would second that, and also say that if you start in production, you need to have solved other stuff first. You need to be sure that your rollbacks and your resilience is a bit higher than usually when you start with chaos engineering, I guess. Because you can lose revenue, and nobody wants to lose money, basically. So, yeah.
So I hope that answers your questions, Om. So next question is again from Alexander. He's asking, can you please elaborate on the documentation part? Where do you store it? How do you manage it?
Yes, we store it in a wiki. We have some templates, so with one click you get a template where you can have the basic parts of an experiment. So your hypothesis, you just have a place where you write down your expectations and
blast radius, participants. You can just and it's basically with little explanations. So you click into the field and then you get the explanation. And if you fill it out, the explanation is gone. This is in German, but it's basically a standard template, and we encourage the teams to customize it, but to keep one or two things we kind of find important, like the hypothesis. You shouldn't delete that, right? So this is something we say, well, maybe that's not a good idea, but besides that, if you need more fields or whatever, add them, that's fine. And it's also good because other teams look at those protocols. They look what the other team do and maybe try it also, especially if they're connected in some way. Like, I don't know, if you book a ticket and you have to pay, maybe they are connected in some way, and then they can benefit from each other. So you look at your neighbors, basically, right? So what have they done? Okay, so they did 2 more game days. Well, okay, this looks good. And then they try to copy it, or they talk to each other, and they replicate their knowledge, basically.
Okay. So since we are on like time bound, I would take a last question, and then we'll wind up the session. And don't worry, whatever questions you have, you can actually join the speaker session channel. We already have a dedicated session channel on Slack, so don't worry, you can directly communicate with the speakers there. So the last question would be, I'll take from again Alexander. How much people are in your team? How much time took the whole process for developing the experiment tooling and experiment conducting the game days? Probably keep it short.
So
Yeah.
at the moment we are 3 to 4 people pushing chaos engineering into the teams, and hopefully we get more support.
Okay. So again, thank you so much everyone for joining. For
Abhishek, before we wind up, probably I have one question and we
Yeah,
can wind
sure.
up then. Hi Oliver, hi Mike. I think I thoroughly enjoyed the talk, and it's been a pleasure to host you both at Chaos Carnival, and I hope you guys are enjoying as well. So last question from my end, as this talk was really interesting personally. So I hope that you have also seen the chaos engineering scene change to cloud native tool sets coming up and open source projects coming up as well in the chaos engineering field. And probably to name a few, I think Litmus, Chaos Mesh, Chaos Blade, Chaos Toolkit, etc. So what's your opinion on these projects, and how do you feel that these projects can come into adoption? What they can improve, or what's the status quo in your mindset?
Yeah. Well, at least for Litmus, I think it's a good idea to be in the cloud native thingy. It really helps to adopt it, I guess. And we didn't have a look at it so far. Maybe we have to. But so far, we decided to check out a product with support, which is sometimes good for big companies. If you can book the support, that someone else is responsible if there's a problem. But so far we just didn't have a look at them, I guess, basically. But it's good that they spread out. I hope that answers it a little bit. Oh,
it kind of does, but Mike, probably looking forward for you to start taking a look at these projects
later in the session.
Sure.
Right. Of course.
Thank you so much, Oliver and Mac. Pleasure hosting
Thank you.
I hope you enjoyed it and you're gonna continue with the conference. Thank you, everyone. See you soon.
Thanks a lot. Bye.